Welcome to our first ever open source observability day. So thank you for everyone who has joined us, whatever time zone it is for you. I know for some it's evening, for some it's morning, maybe middle of the day, somewhere. Let's start by talking about what is observability, right? And the first thing we can do, of course, what we do those days is ask ChatGPT about it, and it will come up probably this response or something similar. But if I talk to people and I want to explain them observability and why it is important, I usually don't go to ChatGPT, right? I like doing this airplane analogy and say, look, guys, when you board a plane, you often probably look inside a cockpit and you can see a lot of different instruments out there. That is really observability. And the reason is aviation is so safe because the observability in it is so great, right? We know about every system in the aircraft is how it is working, right? It's instrumented. And you know what? If something goes wrong with it, we can spot it very quickly and also know what to do about it, right? So the same applies to your application, right? If you want your application to stay up, stay performing well, you need to make sure you have invested in observability. Now, observability has become also important because of growth of complexity of the application. Back in 2000s, early 2000s, I remember applications were often very simple, right? Like you have maybe one application box, one database box, and I remember sometimes you could just, open the shell to, 2-3 servers you have, and if something happens, you tail a couple of logs and run a couple of commands and you figure out what it is, right? Now systems are much more complicated, right? And that means this kind of very primitive manual approach does not work, right? We need to make sure we have some good observability solution. Now, what observability gives us? Well, it helps us to assure availability, performance, reduce cost, ensure application security, right? So it's important on so many levels. And then I think about observability. I like to highlight what that is often helpful both in reactive, right, to deal us with a situation when shit hit the fan, to troubleshoot and optimize things, as well as proactive, right? Knowing, having the things, the application well instrumented, that often means we can find the problems, find opportunity of optimizations, maybe fix the problems before we become big customer impacting problems, right? Which is exactly what you want to do for the business. We also usually have their alerting with with observability, right? That corresponds to the concept which notifies us when a problem happens, and that's a whole other often quite complicated systems when we can manage shifts, notification, escalations, and so on, and so forth, right? Which is important part of observability conceptually. Then we talk about observability. Often you may have heard about like a number of pillars of observability. Some people talk about the 3 pillars of observability. I've seen people mention 5 pillars of observability. Well, I actually picked 4 here. Well, just because that is a number of responses I can have in LinkedIn poll. And I ask the people, what do they consider most important, right? And of course, that's kind of unfair question, right? Because, well, you should not choose, right? I mean, you should have probably all of them or multiple of them. But it is not surprising to me what the metrics is pick people as the most important. I think that is something which has been oldest in the ecosystem, right? That's the most usable and so on and so forth, right? I think metrics are awesome, helping us to see the high level overview, right? We can see how many requests per second are happening, many errors, hosts are down, and in many cases, you will see many thousands of metrics can be collected every second, and that can be displayed through like a different, hundreds of dashboards, thousands of graphs, right? That can be truly overwhelming if not managed well. Now, if you think about logs, and well, I mean different logs when displayed on the picture, that is essentially the records, right, which can come from us from applications, can be structured on unstructured format. And what logs are wonderful for is they have a detailed information of what is happening, right? Error logs contain detailed information about the core of errors and so on and so forth. And in many cases, you can see with metrics on a high level, oh, there seems to be a problem somewhere in that part of my system, but let me take a look at the logs to figure out what's wrong. The problem with logs which exist is they can be expensive to produce, store, and analyze, right? And that means you often have to use some, filtering or sampling to manage the format. The next foundation of the observability from a data point is distributed tracing, right? Their logs come from specific application. Distributed tracing allows us to track the application request as it goes through the system, right? Maybe it goes through your, front end, goes to hit like number of microservices, right? And hit a database or two, right? And that is wonderful. It's very good for root cause analysis, but also it can be very large in volume. And again, that is something which can be expensive to store and produce, and store, right? Especially if you are storing in some cloud solutions, that can be, super expensive, right? So this is example of how distributed tracing visualized could look like. And we can see here where different services like front end, checkout service, product catalog service, right? You can see how much time they took, right? And how those requests overlap in time, right? Because many of them may, happen in parallel, especially in well-designed applications. Then there is a profiling, right? And profiling is wonderful when it can show us where the CPU time or wall clock time is spent. You can profile based on a single server, do distributed profiling. The reason I like the profiling, it uses the language which the developer can understand. If you can tell me and say, hey, you know what, this function what you have in the code, it was taking 10 milliseconds today, and it takes 30 milliseconds, today, and it was 10 milliseconds yesterday. Well, you can ask developer, hey, go and figure out what's happening and optimize your code. That is a very, very actionable for developer, right? Especially if you have some comparison features with that, right? The thing of profiling, of course, is what you want programming language specific support needed, right? Especially for languages like Java or Golang, .NET, right? Which don't specifically kind of map on this sort of like a conventional, C style of functions and objects mapping. This is example how profiling can look like from Coroot, where we have functionality. Both you can see specifically where response time goes, as well as you can compare it to a baseline, right? Let's say selecting their baseline area, right, as well as what is concerning, right, and compare, right, as in this example. So you will see which functions take longer and which functions take less time than before. Okay, now how do we get all this awesome observability? And that is where instrumentation keyword, right, comes about. Right. So to get that data, we need to basically instrument our application so we can, count all those things and capture them. If you think about instrumentation, it comes in two basic ways. One is a sample instrumentation, right? And if you think about Linux kernel, for example, procfs file system, right? It has a lot of counters, which is just, maintain, and through Linux kernel code, there is a lot of those, code. You say, hey, increment this counter or add the current packet size to the network traffic counter and so on and so forth, right? And it is also because it's out there, always available and so on and so forth, but you cannot really cover everything with static instrumentation, right? It's just, too big, too hard. And that is where this dynamic instrumentation comes about, right? Which can say, hey, you know what? we can instrument other probes at the runtime to any place you want, right? And basically instrument anything dynamically. dtrace was the first solution that had to the market, right? But now, especially as we live mostly in a Linux world, eBPF is their technology to focus about, which provides that in the Linux ecosystem. So let's talk briefly now about the key observability technologies, which you should be aware about, right? Even if you are not like somebody who is, specifically focused on observability. One is Prometheus, right? Prometheus has become default standard for this like a new generation of metrics capture and processing, especially if you are looking at cloud native ecosystem, Kubernetes and such, but actually even beyond that, right? Open metrics is also now part of a Prometheus project. And the great thing about this Prometheus ecosystem is it has a client libraries for so many programming languages. And even if it's not integrated in your solution, like for example, MySQL, Postgres, they don't have built-in Prometheus support, but there are some awesome exporters which provide the easy integration of those applications right to Prometheus. The thing though, if you want to expose the metrics from your application through the Prometheus expedition format, you will need to change the code. It's not very hard, but you will need to change the code, which may be hard, for example, for proprietary solutions, which you may not have a code for. OpenTelemetry, that is another technology, which is a very important in open source observability ecosystem those days, which is collection of APIs, SDK, and tools to instrument, generate, collect, and export telemetry data. It actually covers everything, like metrics, logs, and traces. But I think what's distributed tracing is their OpenTelemetry gets the most mind share. Again, to implement OpenTelemetry in your application, right, to get that awesome tracing format, well, you also would need to do some coding in most cases. The next one to mention is eBPF, which I mentioned already. It is a fantastic technology available in Linux kernel, which is not just about observability, but we are interested in observability, right, for us, of course. It allows us dynamic instrumentation in user space and kernel space. It's efficient, it's safe, right? It has a lot of safety, so it's not going to crash your kernel, right, or produce undue performance overhead. And the wonderful thing about eBPF is there is no coding required. Here is example of a website where you can learn more about eBPF. I think you have like some awesome website, one of the best I've seen for like community open source projects, which explains how eBPF works and why is it awesome. Now, let's talk about how we observe, right, our application. On a high level, I think it's very good to think about SLI, service level indicators, which can show us where our application performs as required, expected, or not. I think usable, typical level of SLIs would be something like create requests, right? If you're having too many requests, you may be overloading the system. Availability, error rate, right? If you're having too many errors, right, or timeouts, well, that is a problem, right? You need to look about, right? And also request latency. We typically not just look at the average latency, but something either 99, 95 percentile latency, right? Often we break down by different service points, right? We can say, hey, if my application is going to becoming slow, I need to do something about it. And a good thing about the SLIs, unlike vanity metrics, it makes business, meaning business sense. Now let's talk about the observability problems, which people often complain about. And this is not just limited to open source observability, but just in general. One is hard to deploy. Well, actually, many of you mentioned this one. It's kind of too much effort, too much agent configuration needed, right? Especially in the large and complicated environment, right? Another one which connects to it, it can be hard to cover all the infrastructure, especially for large organizations which may have a bit of everything, right? Saying, hey, we have a bare metal, and we have a cloud, and we have a Kubernetes, and we're doing serverless, right? And we want to make sure we cover everything. And that can be hard, especially with good coverage for everything. And what that means is often what we observe is having something like of a Swiss cheese observability, right? Where you can say, you know what? In some areas, the observability is solid, it's well instrumented, but there are some points, maybe some old legacy applications with no source code running in some obscure old Linux versions, right, or something. They're not instrumented well, and that limits our ability to serve problems. Like think about a plane. What if certain areas of a plane would not be instrumented well, and if problem happens in those areas, well, we can't reliably fix them. Hard to use, right? That's another thing that you guys highlighted as well in your responses. Silos. That is something what we see in the large organizations where we have a lot of different observability tools, teams, managers, which may have a hard to come to agreement if a problem even exists. Noise is another problem, especially when it comes to alerting, right? If you have a lot of alerts triggering all the time, every night, then you have a team fatigue, burnout, alerts are being ignored, and that means increased downtime and bad user experience. Overhead. If you think about the overhead, we think about kind of problems. What if you have a lot of logs, generate a lot of traces, measure a lot of things, we can slow down our applications. And in many cases, I think that's blown out of proportion by some people who have been victims of some very bad instrumentation, right? Somebody took bad decisions and they think like, wow, instrumentation solves things down, 10x. Now there is a cost, right? Proprietary and I think especially cloud observability solutions can get absolutely super expensive, and that is well recognized, right? Because if observability became essential, become not optional, you can essentially push for raising the prices, right? Like Cisco bought Splunk. Why? Well, because they can now they can monetize it very hard, right? I heard about people, they can say, well, you know what, we are spending on Datadog with observability, right? Almost half as much as we actually pay to AWS where we run our services, right? Well, that can be a big problem. Now, as a little bit of a shameless speech, I wanted to highlight about what we do in Coroot to solve some of those problems. Right, and in Coroot we have two editions. Right, to be fair, there has an open source edition which has a lot of things and everything I'm talking about here, and then there is also open core enterprise edition out there. One thing is we use eBPF magic, and that means what we really can get instrumentation rather simple, right? And really get a lot of very valuable data like this, right? We can build a map of all your services, not something what you think your application are doing, right? And how it should communicate, right? What you document in your docs, but actually what services you actually have deployed and how they're talking to you about, right? And that is awesomely useful. We have seen so many people discovering things about the applications they hope they wouldn't ever discover. We also integrate with information from the cloud vendors, so we can help you to understand the costs, and not only cost running the nodes, but also costs of the traffic that we break down on per application, which is, I think, one of the very cool features what we have. So what we do specifically in Coroot about handling those observability problems? Well, if you think about hard to deploy, we really focus on making sure you get 90% of the value without any configuration whatsoever. Yes, you can provide, for example, your PostgreSQL credentials to get more data, but most of the data about the queries, about the latencies, will be discovered automatically through magic of eBPF. We also made sure what Coroot is, while it works also with Kubernetes, it also works with containers, it works with cloud, with VMs, with bare metal, you name it. So you can really deploy it for all your environment. In terms of hard to use, our focus has been providing you more actionable insight and less raw data, right? Lack of actionable insight, that is another thing you guys highlighted as important concern with the open source dashboard. We also have to deal with silos, with complete infrastructure coverage and really evidence-based root cause analysis, so everybody in the team can agree about what is the state of a problem. When it comes to noise, our focus has been rather simple, right? We want to make sure we focus on objective measures like SLI rather than vanity metrics. You know what? Because these are what really matters to get you out of bed. And then, you know what, during the day, yes, you probably want to review various, other metrics, but which are not actually impacting production to do some proactive stuff. But our belief is when it comes to alerting, less is often more because noise is so more problematic. We also manage the overhead well because the eBPF is this modern technology which is designed for speed. We provide the open source solution that will help you to control the cost, right? And a lot of technologies what we use, such as a ClickHouse, is a very efficient, highly optimized storage you can use, as well as with various configuration options. You can control a lot of things, right? With flexible data retention and so on. Okay, now we came to the last slide, where I will finish up by some of my word of advice, how I would recommend you guys to approach your observability environment. One thing is ensure your observability is complete with no blind spots, right? No Swiss cheese. Then ensure you have a tools which identify the components experiencing the issue. That is often the hardest to find agreement. Is it a database problem, application problem, maybe storage problem, a network problem, right? If you don't know exactly where the problem is, you may be looking in the wrong place and waste a lot of time. Also, make sure you use skill-appropriate tools. Less can be more. Thousands of dashboards can be overwhelming, and that is where you can look for that essential actionable advice, right, and actual insights where the problem is, right, and what you can do about that, right? And also make sure you have a tool which produces you enough evidence so you can escalate that to another team or the vendor, right? So they cannot go and say, no, that is not our problem. Look somewhere else. Everything looks fine here, right? The good tools should provide that. And that is all I have. I will be happy to answer your questions in the background, and we will have other sessions starting up shortly.